This lesson's on 10.5, writing scientific notation. So example 1, a number is written in scientific notation when it is represented as a product of a factor and a power of 10. We have an 8.3, which is a factor. We have times 10, and the power of the base 10 is negative 7. The factor must be greater than or equal to 1 and less than 10. So for the position of 8, that number has to be between 1 to 9. You cannot have a 0 and you cannot have a 10 because 10 is a 2-digit number. So it will always be a 1-digit number. If it's a 2-digit number, then it is not in a scientific notation. And then from the exponent of the base 10 can either be positive or negative number. Example 2, tell whether the number is written in scientific notation. So we're looking at our first number, and our first number is 0. That is not in the correct scientific notation because the number has to range between 1 to 9. And so if we wrote that into the correct scientific notation, our first factor number would be then 2.6, and then we would have to change our exponent because we have moved our decimal place. But we'll talk about the movement in the next examples. But we want to make sure that our factor is always a 1-digit number and it ranges between 1 to 9. In example 3, writing numbers in standard form. So when we have an exponent, in this case we have an exponent of negative 4, we're going to move our decimal places to make it in a standard form. Right now, this is in scientific notation. So when we write in standard form, just think of it as a number line. When we have 0 and all the positive numbers are on the right hand side and all the negative numbers are on the left hand side. So in this case, I'm going to take my factor of 3.22, and because the exponent is negative 4, we're moving to the left side. So we have is 1, 2, 3, and 4, and we're going to fill in those gaps with zeros. We have a 0, a 0, and a 0. So our final number becomes 0, and we always want a 0 when you have a decimal place, so 0 point, and we have 3 zeros, so 1, 2, 3, 3, 2, 2, and this will be in standard form. In example 4, we have 7.9 times 10 to the 5th power, and the 5 is a positive exponent, and we want to change this into a standard form instead of a scientific notation. So again, as stated before, on a number line, when we have a 0, negative is on the left, positive is on the right. So we're going to take our factor of 7.9 and we're moving it 5 places over to the right. So there's 1, 2, 3, 4, and 5. And we're going to fill in those gaps with zeros in there. And so our final number then becomes 79 with 4 zeros, 1, 2, 3, 4. And usually after the 3 places over, we like to put a comma so it's easy to read. In example 5, we're going to now go backwards and write this number into a scientific notation. So when we write this in scientific notation, as we stated before, the factor number has to be a 1-digit number. So in our case, 3 is our 1-digit number. We're going to put a decimal. All the numbers will follow after the decimal place. So 4, 5. And we don't put the zeros because that's what the notation, the scientific notation of x to the 10th power will give us. So to find out what the power is, we're going to go ahead. I'm going to rewrite this 4, 5, 0, 1, 2, 3. And so our decimal place is going to be after this 3 right here, and we're going to move it to the back. So we're going to go 1, 2, 3, 4, 5, 6. Since we moved 6 places to the right, our exponent is to the 6th power positive. In our example 6, writing the scientific notation, we're doing the same thing. our first number factor would have to be a number that is between 1 through 9. So none of the zeros will work. So with the first number that we come across will be then 7. And then we would have is 7.89 times 10. And now we have to figure out is the exponent. So I'm going to rewrite the problem of 0.123450789, and we're going to move that. So right now it is 7.89, and we're going to move it to where the decimal ends. So that's 1, 2, 3, 4, 5, 6 places over. So it's going to be -6 because I moved it 6 to the left.